All right, today we are on day 3 and starting matrices. So matrices really are just a rectangular arrangement of numbers in rows and columns. And I had some information I was going to share with you on this, if I can find it. They are used to represent and solve complex problems in various fields. You can do linear and other systems. They're often used to model data in computer graphics, physics, machine learning. They store and manipulate data in fields like engineering, robotics, quantum mechanics, economics. So they are actually used out there. So today we're going to get a quick look at them, and we will add, subtract, do scalar multiplication and regular multiplication. So here we go. The dimensions of a matrix, whenever you're talking about the dimensions, we always do the number of rows by the number of columns. Okay, so it's always row by columns. When you're talking about the element, you are talking about the actual numbers in a matrix. So like matrix A has 6 elements in it. So when you go to explain what the element is, you'll see here, this is matrix A, and it's not the number 23, it's 2. This is row 2, column 3. So again, when we look at matrix, we look at rows and columns. And so matrix A, let's talk about this real quick. Matrix A actually has 3 rows by 2 columns. So it is a 3 by 2 matrix. B has 2 rows and 1, 2, 3 columns. It is a 2 by 3. And see if you can do C. Sue? Who's Sue? Do C. It is a 3 by 1 matrix. So now that you understand it's row by column, you can go up and find each element they're asking for. So in matrix A, look on the second row, which would be right here, and the third column. Guess what? There is no third column over there. So there is none. It's undefined there. We don't have an element there. It was a tricky one to start with. Oh, well. Then we go to C. Go to row 1, column 2. Oh my gosh, how mean can we be? We just did another none. That's undefined. There is nothing there. I'm trying to remember if it says undefined or none. Okay, we're going to have one for this one. I'm feeling good. Go to matrix A, row 3, column 2 is a 6. Yay, we got an answer. Go see if you can find B23. So B, row 1, row 2, the third column would be a 9. Now, as easy as these are, you'll see these show up on a quiz or a test. And some of you will forget how to do them because it's so easy. You never go back and look. So make sure you follow with that. All right. So next we're going to add and subtract matrices. Super easy, but something that you have to know is they have to be the same dimension before you can do it. So let's practice finding our dimensions again. Okay, so let's go. This first one, we have 3 rows by 1 column. It's pretty obvious to see these guys are the same dimension, but again, we're going to practice. 3 rows by 1 column. Yes, they have the same dimension. So all you're going to do is actually add, and I will write this out one time only. We will go 2 plus 4, 3 minus 1, and 0 plus 5. Boom. So once you add those, you get 6, 2, 5. So easy. That's how you add your matrices. Okay, example 2. We are subtracting, and it's the exact same thing. We will, and I'll write it out. You guys probably don't need it. 1 minus 5. That will be my top number. 2 minus 6, 3 minus 7, and 4 minus 8. Then you simply simplify those, and if I can do this right, we get a negative 4, a negative 4, a negative 4, a negative 4. It's like the 444 commercial that you hear and hate so badly. So if you notice, this was a 2 by 2 matrix. This was a 2 by 2. And guess what my answer was? A 2 by 2. And this down here was a 3 by 1. When you add matrices, they have to be the same dimension. Your answer will be the same dimension. Example 3. I have a 2 rows by 1 column, 2 rows by 2 columns. We cannot add. They have different dimensions. Different dimensions. No add these. All right, adding, subtracting, pretty simple. I'm going to keep rolling. Pause anytime because I'm going to move quick. Scalar multiplication. This is where you can, now this is different from regular multiplication. This is where we have one number on the outside. It will be different than multiplying two matrices. These, I think, are easy peasy. You can multiply any matrix by a constant. And I'm not going to write this out. All you're going to do is multiply 2 times every single part. So rock and roll, you can do it, and we'll see if we get the same thing. There you go. Can you multiply? Probably the bigger question is, can I multiply correctly? And yes, I did multiply correctly. Go, Miss Moore. Number 5, we're just distributing. The negative is all you do. And so your answer will be a +1, +2 matrix. We're going to get a little bit fancier on the next one. We are going to multiply the 3 times our first matrix, multiply the 2, and then combine them. So you do it. Check it with me as you go. We'll multiply the 3 times all of these elements. And then we will multiply 2 times all of the elements in the second matrix. And then we will simply add each element. So our first position gets added with the second one. And we get a 7. We get a 7. Well, is it going to be all 7s? Nope. -8 and 6. So there we go. Adding, subtracting, multiplying. Super easy. Guess what? It says combination, multiplication with addition. Well, by golly, guess what? We just did that right up there. How funny. But we've got some more, and maybe we won't do all of these. Here, they're giving you the letters instead of the actual matrix. But you know what? We pretty much just did that one up there. I think might be more fun. We'll do it really quick. Multiply 2 times all of your A matrix. And we're just going to roll quickly because we got to get to the hard stuff. And we're going to add that with the B matrix. And I'm not going to rewrite the B matrix. So 2 plus a -2 is 0. 0 plus 1 is 1. 10 plus 3 is 13. And -12 plus 4 should be a -8. There we go. Now, example 8, they actually want us to add A and B first and then multiply by 2. So let's switch colors for fun. 2, and now let's go ahead and add A and B. So 1 minus 2 should be a -1. 0 plus 1 is 1. 5 and 3 is 8. Probably be easier if I'd be quiet and just let you do this, huh? Now multiply 2 times everything. And we get a -2, a +2, 16, and -4. Woo, these are going quick. Love it. And lastly over here, we're going to add 2A plus C. You know what I've not been checking like I should be? Is we really need to make sure these were the same dimensions. And obviously, these are both a 2 by 2. Guess what this one is? This is a 2 by 1. Can we add if the dimensions are not the same? And no, we cannot. Different dimensions. Can't add. All right, that made that one fast. All right, and we're going to really quick talk about solving matrices before we get into really the heart of the lesson. And the harder part is the multiplying. So let's blow this up. And you go solve matrices. I really think I could cut you loose, and if I was in class, I probably would, and have you see what you think you might be able to do. Because I notice right away I've got an X here. I've got a Y over there, and I'll look for that one in a second. But you know, when we add matrices, we add each location. This is in row 1, column 2. That's going to go with row 1, column 2 here. And when I add those, it tells me I should equal 12. So these are like a little puzzle, kind of like them. So this means 5x plus 2 should equal 12. And there we go, can solve that out super quick. 5x equals 10, x is 2. And so now you maybe go, oh, I think I can do y. I'm hoping you're feeling that way, because you go, here is my y. That's in row 1, column 1. So that goes with all of these other elements. I know that if I add 4 plus, that's a negative 11, I should get y. Oh, that one was an easy one, right? We've got negative 7 equals y, and we found our x, we found our y. Next problem, if you want to pause me and you go try it, go for it. This one's a little different, and you could do it a couple ways. I am going to write out my equation for the x's, but noting I've got this 3 out here. So I'm really going to have 3 times 5x plus 3, and that should equal a negative 21, if I do the math right. And so solve that one out super quickly. We have 15x plus 9. I will be quiet a minute. I got x equals a negative 2. And then solve for your y. And I'd say pause it really quick. Go try this. See if you can get it. Find all your y positions. And don't forget your 3. Now we're going to have some noise coming on as well.
If you purchased a homecoming ticket and have not picked it up yet, you must pick it up from the AG's office today before 3:30 p.m. At this time, we are going to send football, volleyball, and homecoming court to head towards the gym to get ready for the pep wrestling. That's only football, volleyball, and homecoming court.
Woo! I knew they were going to come on with that announcement, but you know what? Here we rolled. You know, I decided to do this one different. Instead of distributing, I divided by 3. You still should get the same answer regardless. All right, we may get interrupted again, but we're going to get to matrix multiplication. And this is where it is, that to me was easy peasy stuff. This is going to get where you got to pay attention. Not really hard, but you got to pay attention. So when you multiply matrix A times matrix B, they don't have to be the same dimension, but the number of columns in A must be equal to the rows in B. The number of columns in A must be the same as the rows in B. So let me see if we can talk this through. Okay, so in other words, I need to find my rows and columns. So let's go over here and see if you can jot down, if we've got it down, how many rows and how many columns we have here. So this is a 4 by 3. And this one down here is a 3 by 2. All right, so A, we realize it is a 4 by 3. B is a 3 by 2. So I want to know, is the number of columns in my first one equal to the number of rows in the second one? And yes, these match. So yes, I can multiply these guys. Okay, now it matters now, like when we added these, it really doesn't matter the order that you put these when you add, because you're still going to get the same answer. When you multiply, it makes a huge difference. Because if we switch and put the B first, now I want to multiply a 3 by 2 with a 4 by 3. These do not match. So no, you cannot multiply that way. So it's super important to check your dimensions first. Now here's the cool thing. When you get your answer for this first one, it will be a 4 by 2. It'll be your outside numbers. It will be this row by that column. Okay, so not hard, but we're going to go slow because they are a bit tricky. And I'm just going to do it. What you do when you multiply matrices, you multiply the rows of the first matrix with the columns of the second. Okay, so we're going to start off. This is a 2 by 2. This is a 2 by 2. So I should be able to do either one of these because my columns will match my rows either way I write this. And my answer should end up giving me a 2 by 2. All right, so we're going to start off and go slow. So we now have, we're going to use the rows. So I'm going to multiply this row by this column first. Okay, so I will do 1 times 5, and I'm going to add that with 2 times 7. And that will be that first element in this matrix. Now I will take the same row and multiply it by the second column to get this element over here. We'll do the same thing. We'll take 1 times 6 and add it to 2 times 8. And there we've done our first row with both columns. Now we're going to switch. We're going to take the second row and multiply it with each column. So I will take 3 times 5 and add it to 4 times 7. Then we will start and go to the second one, second column. So 3 times 6 plus 4 times 8. So it really isn't that hard, but it is open to make tiny mistakes. So I suggest you go slow and actually write these out, at least until you're really good. And I never really get really good at these. So here we go. So 1 times 5 is 5 plus 14. 5 and 14 give me 19. Here we go again. I'm going to finish.
All right, heroes. We're going to go ahead and use the freshmen and the juniors and put a pepper on it. That's freshmen and juniors.
I am just multiplying and adding. That would be 30, 43, trying not to make mistakes. On a video, 18 plus 32, and that gives me 50. Ooh, there we go. These are a little more complicated. Okay, now we're going to take and we're going to switch, and we're going to find out you don't get the same answer when you switch the order. So I'm going to actually come down here and write my matrices again, 5, 7, 6, 8, because now I'm going to be using the rows of B with the columns of A. All right, so we're going to go slow. Row by column. We get 5 times 1 plus 6 times 3. Now go to the next one. 5 times 2 plus 6 times 4. Ooh, rock and roll. Okay, the bottom one, bottom row. we start with our columns. 7 times 1 plus 8 times 3, and then 7 times 2 plus 8 times 4. And you know, when you're doing these, I do write mine out because I don't want to make mistakes, but you can look across and these all should be 1, 1, 2, 2, 3, 4, 3, 4. Down, they should be 5, 5, 7, 7, 6, 6, 8, 8. I can quickly check mine and go, wow, those numbers match. 5, 6, 5, 6, 7, 8, 7, 8, to make sure I've not made a stupid mistake, because I am prone to stupid mistakes. So we have 5 plus 18. 5 plus 18 gives us 23. We have 10 plus 24, 34. 7 plus 24, 31. And that would be 14 plus 32, bigger numbers, 46. All right. So we have one more down here. Let's see, can we multiply it? And do I have time before the pep rally? Hey, we'll find out. This is a 2 rows by 2 columns. This is a 2 row by 3 columns. Yes, we can multiply because that matches. The columns matches these rows, and my answer should be a 2 by 3. I was thinking about letting you work this out, but let's see if we can do this. There's a lot of zeros that's going to make this easy. So we will get 1 times, I'm going to do this a little bit together. 1 times 1 is 1, plus 0 gives me 1. I don't know if I should do this. 1 times 3 is 1, or 3, plus 0 times negative 1, well, it's still 0, so I have 3. 1 times 5 is 5, and it doesn't change that. There we go. Those are the first. Now we take the second one, and we have zeros. This makes it so easy. 2 times 1 is 2, plus 0. 2, I may write this one down. I have a 2 times 3, which is 6, plus negative 1 times negative 1 plus 1. That will give me 7. And the last one will be 2 times 5, which is 10. Negative 1 times 2 is a negative 2, which is 8. So there we go. Hopefully you can multiply. Again, they're not hard, but it's easy to make little mistakes. So be careful, and I will see you when I get back. Stop record.